The universe is vast, almost beyond comprehension, and within its endless expanse lies a mystery that has captivated humanity for generations. What if, hidden among the stars, there are messages waiting to be decoded? Signals from civilizations far beyond our own, reaching out across the cosmos. Today, we're diving into 25 of the most mysterious messages ever detected from deep space. From unexplained bursts of energy to strange patterns that defy explanation, these signals have left scientists and dreamers alike questioning whether we're truly alone. Could these be the whispers of extraterrestrial intelligence, or are they simply the universe playing tricks on us? Stay with us as we unravel these cosmic enigmas, one signal at a time. By the end of this journey, you'll not only discover the stories behind these mysterious messages, but also find yourself wondering what else might be out there, waiting to be found. Let's begin. Now, let's turn our attention to one of the most famous and puzzling signals ever detected, the WOW signal. Discovered in 1977 by astronomer Jerry Ayman, this signal has become a cornerstone in the search for extraterrestrial intelligence. What made it so extraordinary? For starters, it was incredibly intense, lasting for 72 seconds, and it came through on a very narrow frequency band, a characteristic that's hard to explain through natural cosmic phenomena. Ayman was so stunned by the data that he circled it on the printout and wrote "WOW" next to it, giving the signal its iconic name. The WOW signal originated from the direction of the constellation Sagittarius, but despite decades of searching, no repeat signal has ever been detected. This has led to a whirlwind of theories. Some scientists believe it could have been a one-time event, like a burst of energy from a distant star or even a passing comet. Others, however, argue that its narrow frequency and intensity suggest it might have been an intentional transmission from an advanced civilization. The mystery deepens when you consider that no natural process we know of can fully explain its unique properties. To this day, the WOW signal remains unexplained, a tantalizing clue that keeps the possibility of extraterrestrial communication alive. Could it have been a fleeting hello from a distant world, or just a cosmic coincidence? The answer, for now, remains hidden among the stars, and as we move forward, this signal reminds us that the universe is full of surprises, waiting for us to uncover them. Next, we'll explore another enigmatic message from the depths of space, the Lorimer Burst. Shifting our gaze to another cosmic enigma, we arrive at the Lorimer Burst, a fleeting yet powerful signal that has left scientists both fascinated and puzzled. Discovered in 2007 by astronomer Duncan Lorimer, this fast radio burst, or FRB, lasted just a few milliseconds but packed an astonishing amount of energy equivalent to what the Sun emits in 30,000 years. What makes this burst so intriguing is its sheer intensity and the fact that it came from a region of space billions of light years away, far beyond our own galaxy. The Lorimer Burst was the first of its kind to be detected, and its discovery opened up an entirely new field of study in astronomy. Fast radio bursts are incredibly brief, making them difficult to detect and even harder to study. But their immense energy suggests they originate from some of the most extreme environments in the universe. Scientists have proposed a range of explanations for these bursts, from the collapse of massive stars to the merging of neutron stars. Yet, the exact cause remains a mystery. Adding to the intrigue, some researchers have speculated that FRBs could be artificial in origin. Could they be signals from advanced civilizations, perhaps used for communication or even as a means of powering interstellar spacecraft? While this idea is speculative, it's not entirely dismissed, especially given the burst's unique properties. The debate continues, with some arguing that natural cosmic events are the more likely explanation, while others keep the door open to the possibility of extraterrestrial technology. What's clear is that the Lorimer Burst has fundamentally changed how we think about the universe. It's a reminder that even the briefest signals can carry profound implications, challenging us to rethink what we know about the cosmos. As we continue to explore these mysterious bursts, one thing is certain: they hold secrets that could reshape our understanding of space and our place within it. Next, we'll delve into another puzzling signal that has sparked similar debates, the SHB-02 plus 14, a signal. Turning our attention to another cosmic mystery, we encounter the SHB-02 plus 14, a signal, a detection that has sparked both curiosity and debate since its discovery in 2003. This signal, picked up by the SETI at Home project, stood out due to its unusual frequency close to the hydrogen line, a frequency many scientists believe could be a natural choice for extraterrestrial communication. Hydrogen is the most abundant element in the universe, and its emission line is often considered a universal watermark for potential interstellar messages. But what made this signal particularly intriguing was its apparent movement, which seemed to align with the rotation of Earth, suggesting it might be coming from a nearby star system. However, pinpointing the origin of the SHB-02 plus 14, a signal, has proven to be a significant challenge. The signal was faint, intermittent, and difficult to trace, leaving researchers with more questions than answers. Some have speculated that it could be the result of interference from Earth-based sources, such as satellites or even terrestrial radio signals bouncing off space debris. Others, though, have entertained the possibility that it could be a genuine attempt at communication from an alien civilization. The idea that an advanced species might use the hydrogen line as a beacon is not far-fetched given its universal significance. Yet, without more concrete evidence, the signal remains shrouded in uncertainty. The SHB-02 plus 14, a signal, also highlights the broader challenges of searching for extraterrestrial intelligence. Detecting a signal is one thing, but verifying its origin and deciphering its meaning is an entirely different challenge. The vastness of space, combined with the limitations of our current technology, means that even the most promising signals can slip through our fingers. This signal, like many others, serves as a reminder of how much we still have to learn about the cosmos and the potential for life beyond our planet. As we continue to explore the mysteries of deep space, the SHB-02 plus 14, a signal, remains a tantalizing piece of the puzzle. Whether it's a cosmic coincidence or a deliberate message from another civilization, it pushes us to keep searching, questioning, and imagining what might be out there. Next, we'll take a closer look at a message that was intentionally sent from Earth, the Arecibo message, and the fascinating story behind humanity's first deliberate attempt to communicate with the stars. Now, let's shift our focus to a message that wasn't just received but was sent by us, the Arecibo message. In 1974, humanity took a bold step toward the stars by transmitting a deliberate signal into the cosmos. This historic message was beamed from the Arecibo Observatory in Puerto Rico, one of the most powerful radio telescopes of its time, toward a globular star cluster known as M13, located approximately 25,000 light-years away. The goal: to announce our presence to any potential extraterrestrial civilizations that might be listening. The Arecibo message was a carefully crafted binary code, a series of ones and zeros that, when decoded, revealed a wealth of information about humanity and our planet. It included details about the structure of DNA, the chemical elements essential for life, a depiction of the solar system, and even a stick figure representing a human. The message was designed to be universal, using symbols and concepts that could, in theory, be understood by any intelligent species capable of interpreting binary code. It was humanity's first intentional attempt to communicate with the cosmos, a cosmic hello, sent with the hope of one day receiving a reply. But why M13? This globular cluster was chosen because it contains hundreds of thousands of stars, increasing the odds that the message might reach a civilization capable of understanding it. However, given the immense distance, even if the message were received and decoded, a response would take at least 50,000 years to reach us. This raises an intriguing question. Was the Arecibo message more about making a statement than expecting a reply? Some argue that its true significance lies in its symbolic value, a testament to humanity's curiosity and our desire to connect with the unknown. The Arecibo message also sparked debates about the ethics and risks of sending signals into space. While some see it as a hopeful gesture, others worry about the potential dangers of revealing our existence to an unknown and possibly hostile civilization. This tension between optimism and caution continues to shape discussions about future attempts at interstellar communication. Despite its symbolic importance, the Arecibo message remains a one-way conversation, a single note in the vast symphony of the universe. Yet, it serves as a powerful reminder of our place in the cosmos and our enduring quest to find answers to the biggest questions of all. Are we alone? And if not, who might be out there waiting to hear from us? As we ponder these questions, let's turn our attention to another cosmic mystery, the strange dimming patterns of KIC 8462852, also known as Tabby's star. Now, let's journey to a star that has baffled astronomers and sparked imaginations worldwide. KIC 8462852, better known as Tabby's star. Located roughly 1,400 light-years away in the constellation Cygnus, this star has become famous for its bizarre and unpredictable dimming patterns. Unlike most stars which dim in regular, predictable cycles, Tabby's star experiences sudden and dramatic drops in brightness, sometimes by as much as 22%. These dips are irregular, lasting anywhere from days to weeks, and they don't follow any obvious pattern. This unusual behavior has led to a flurry of speculation, with some even suggesting that the star might be surrounded by alien megastructures. The mystery began in 2015 when citizen scientists analyzing data from NASA's Kepler Space Telescope flagged the star's strange light patterns. The data revealed that the star's brightness would drop dramatically at random intervals, far more than what could be explained by a passing planet or even a swarm of comets. One of the most striking theories proposed to explain this phenomenon is the idea of a Dyson sphere, a hypothetical megastructure built by an advanced alien civilization to harness the energy of their star. According to this theory, the irregular dimming could be caused by massive structures orbiting the star, partially blocking its light as they pass in front of it. However, not everyone is convinced by the alien megastructure hypothesis. Scientists have proposed several natural explanations for the star's behavior. One possibility is that the dimming is caused by a massive cloud of dust and debris, perhaps from a shattered planet or a swarm of comets. Another theory suggests that the star itself might be undergoing internal changes, such as magnetic activity or pulsations that could affect its brightness. While these natural explanations are plausible, none have fully accounted for the star's extreme and irregular dimming, leaving the mystery unsolved. What makes Tabby's star so fascinating is not just its strange behavior, but also what it represents in the search for extraterrestrial intelligence. The idea of alien megastructures, while speculative, captures the imagination and highlights the potential for discovering signs of advanced civilizations beyond our solar system. Even if the dimming turns out to have a natural cause, the star has already reshaped how we think about the universe and our place within it. It reminds us that the cosmos is full of surprises, and sometimes the most extraordinary explanations are worth considering. As we continue to study Tabby's star, one thing is clear. It challenges our understanding of stellar behavior and pushes us to think beyond conventional explanations. Whether the answer lies in alien technology or a yet-to-be-discovered natural phenomenon, this star has become a symbol of the endless possibilities that await us in the vast expanse of space. And with that, let's turn our attention to another intriguing signal, the BLC-1 signal detected by the Breakthrough Listen project in 2020. Now, shifting our gaze to a more recent discovery, we arrive at the BLC-1 signal, a tantalizing candidate in the search for extraterrestrial intelligence. Detected in 2020 by the Breakthrough Listen project, this signal immediately captured the attention of scientists and enthusiasts alike. Originating from the direction of Proxima Centauri, our closest stellar neighbor just over 4 light-years away, the BLC-1 signal stood out due to its narrowband frequency, a characteristic often associated with artificial rather than natural sources. This made it a prime candidate for further investigation, sparking hopes that it might be a deliberate message from an advanced civilization. The Breakthrough Listen project, a global initiative dedicated to scanning the skies for signs of intelligent life, identified the signal using the Parkes Observatory in Australia. What made BLC-1 particularly intriguing was its frequency of 982 MHz, a range typically free from interference caused by human-made satellites or aircraft. Additionally, the signal exhibited a drift rate, meaning its frequency shifted slightly over time, which could suggest it originated from a moving source, such as a planet orbiting a star. These features aligned with what scientists might expect from a technologically advanced civilization attempting to communicate across the cosmos. However, as with many signals in the search for extraterrestrial intelligence, or SETI, the excitement surrounding BLC-1 was tempered by the challenges of confirming its origin. While the signal's characteristics were promising, they were not definitive proof of alien communication. One of the primary hurdles was the possibility of terrestrial interference. Despite the careful filtering of human-made signals, there's always a chance that an unknown source of interference could mimic the properties of an extraterrestrial transmission. Additionally, the signal was detected only once, making it difficult to verify its authenticity or pinpoint its exact source. Without repeated observations, scientists couldn't rule out the possibility of a rare but natural astrophysical phenomenon or even an undetected glitch in the equipment. The BLC-1 signal also highlights the broader challenges faced by SETI researchers. Even when a signal appears promising, confirming its extraterrestrial origin requires meticulous analysis and ideally repeated detection. The vastness of space, combined with the limitations of our current technology, means that many signals remain tantalizing mysteries rather than definitive discoveries. Yet, each candidate like BLC-1 brings us one step closer to understanding whether we are alone in the universe or part of a larger cosmic community. As we reflect on the BLC-1 signal, it serves as a reminder of both the excitement and the complexity inherent in the search for extraterrestrial intelligence. While the signal's origin remains unconfirmed, its discovery underscores the importance of continued exploration and the need for advanced tools to unravel the mysteries of the cosmos. With that in mind, let's turn our attention to another enigmatic signal, this time from the Rattan 600 radio telescope in 2016. Now let's journey to the year 2016, when the Rattan 600 radio telescope in Russia detected a signal that sent ripples through the scientific community. This signal, originating from the direction of a star system known as HD 164595, located approximately 94 light-years from Earth, sparked both excitement and skepticism. The Rattan 600 telescope, renowned for its ability to scan vast swaths of the sky, picked up a burst of radio waves that seemed to stand out from the usual cosmic noise. What made this signal particularly intriguing was its proximity to a star system that had already been flagged as a potential candidate for hosting habitable planets. The signal's characteristics were unusual enough to raise eyebrows. It appeared to be a narrowband transmission, a feature often associated with artificial sources rather than natural astrophysical phenomena. Narrowband signals are considered a potential hallmark of intelligent communication because they require precise engineering to produce, unlike the broad, chaotic emissions typically generated by stars or other cosmic objects. This led some researchers to speculate that the signal could be a deliberate attempt at communication from an advanced extraterrestrial civilization. The star system HD 164595, with its Sun-like star and potential for hosting Earth-like planets, only added fuel to the fire of speculation. However, as with many signals in the search for extraterrestrial intelligence or SETI, the initial excitement was met with a healthy dose of skepticism. One of the primary challenges was the signal's lack of repetition. Unlike the repeating fast radio bursts we've discussed earlier, the Rattan 600 signal was detected only once. This made it difficult to confirm whether it was a genuine extraterrestrial message or simply a rare but natural cosmic event. Additionally, the possibility of terrestrial interference couldn't be entirely ruled out. Even with advanced filtering techniques, human-made signals from satellites, aircraft, or other sources can sometimes mimic the properties of an alien transmission. The scientific community's response to the Rattan 600 signal was a mix of cautious optimism and rigorous scrutiny. Researchers emphasized the need for follow-up observations to determine whether the signal could be detected again. Without repeated detections, it's nearly impossible to confirm its extraterrestrial origin. This highlights a recurring theme in the search for alien messages: the need for patience and persistence. While a single signal can spark hope, it's only through repeated observations and meticulous analysis that we can move closer to answering the profound question of whether we are alone in the universe. The Rattan 600 signal also underscores the importance of international collaboration in the search for extraterrestrial intelligence. The detection was made possible by a Russian telescope, but its implications were discussed and debated by scientists around the world. This global effort reflects the shared curiosity and determination to uncover the mysteries of the cosmos. While the signal's origin remains unconfirmed, its discovery serves as a reminder of the vastness of space and the endless possibilities it holds. As we move forward, the Rattan 600 signal invites us to consider the broader implications of detecting a potential alien message. What would it mean for humanity if we were to confirm that we are not alone? How would such a discovery reshape our understanding of our place in the universe? These are questions that continue to drive the search for extraterrestrial intelligence, and each new signal, like the one from Rattan 600, brings us one step closer to finding answers. With that in mind, let's turn our attention to another intriguing signal, this time from the star HD 164595, which we'll explore in the next section. Now, shifting our focus to another fascinating signal, we arrive at the star HD 164595, which made headlines in 2015. This star, located approximately 94 light-years from Earth, became the center of attention when a mysterious signal was detected emanating from its direction. The signal, captured by the Rattan 600 radio telescope in Russia, was unlike anything typically observed in the cosmos. It was a narrowband transmission, a type of signal that stands out because of its precision and focus, characteristics often associated with artificial sources rather than natural cosmic phenomena. What made this signal particularly compelling was its potential connection to a star system that had already been identified as a candidate for hosting habitable planets. HD 164595 is a Sun-like star, and its similarity to our own solar system raised intriguing questions. Could this signal be a deliberate attempt at communication from an advanced civilization? The idea wasn't far-fetched, given that narrowband signals require a level of technological sophistication that natural processes rarely produce. This led to widespread speculation about the possibility of extraterrestrial intelligence behind the transmission. However, as with many signals in the search for extraterrestrial intelligence, or SETI, the excitement was tempered by skepticism. One of the primary challenges was the signal's lack of repetition. Unlike some of the repeating fast radio bursts we've discussed earlier, The HD 164595 signal was detected only once. This made it difficult to confirm whether it was a genuine extraterrestrial message or simply a rare but natural cosmic event. Additionally, the possibility of terrestrial interference couldn't be entirely ruled out. Human-made signals from satellites, aircraft, or other sources can sometimes mimic the properties of an alien transmission, adding another layer of complexity to the analysis. The scientific community's response to the HD 164595 signal was a mix of cautious optimism and rigorous scrutiny. Researchers emphasized the need for follow-up observations to determine whether the signal could be detected again. Without repeated detections, it's nearly impossible to confirm its extraterrestrial origin. This highlights a recurring theme in the search for alien messages: the need for patience and persistence. While a single signal can spark hope, it's only through repeated observations and meticulous analysis that we can move closer to answering the profound question of whether we are alone in the universe. The HD 164595 signal also underscores the importance of international collaboration in the search for extraterrestrial intelligence. The detection was made possible by a Russian telescope, but its implications were discussed and debated by scientists around the world. This global effort reflects the shared curiosity and determination to uncover the mysteries of the cosmos. While the signal's origin remains unconfirmed, its discovery serves as a reminder of the vastness of space and the endless possibilities it holds. As we reflect on the HD 164595 signal, it invites us to consider the broader implications of detecting a potential alien message. What would it mean for humanity if we were to confirm that we are not alone? How would such a discovery reshape our understanding of our place in the universe? These are questions that continue to drive the search for extraterrestrial intelligence, and each new signal, like the one from HD 164595, brings us one step closer to finding answers. With that in mind, let's turn our attention to another intriguing signal, this time from the star Ross 128, which we'll explore in the next section. Now, let's journey to a discovery that changed the way we think about fast radio bursts, the first repeating fast radio burst ever detected, known as FRB 121102. Discovered in 2015, this signal stood out from the rest because it didn't just flash once and disappear. Instead, it repeated multiple times, sparking a wave of excitement and intrigue among astronomers and SETI researchers alike. Fast radio bursts, or FRB, are incredibly powerful bursts of radio waves that last just milliseconds. Most of them are one-off events, making them nearly impossible to study in detail. But FRB 121102 was different. Its repeating nature allowed scientists to observe it multiple times, opening up new possibilities for understanding these mysterious cosmic phenomena. The origin of FRB 121102 has been a subject of intense debate. One of the leading theories suggests that it could be linked to a highly magnetized neutron star known as a magnetar. Magnetars are known for their extreme magnetic fields, which can produce bursts of energy. However, the sheer power and regularity of FRB 121102 have led some to wonder if it could be something even more extraordinary, perhaps a sign of advanced extraterrestrial technology. This idea isn't as far-fetched as it might sound. The signal's repeating pattern and precise timing have fueled speculation that it could be a deliberate attempt at communication. Some have even proposed that it might be a beacon or a propulsion system used by an advanced civilization. While these theories are speculative, they highlight the tantalizing possibilities that FRB 121102 presents. On the other hand, natural explanations remain the most widely accepted. The signal's location, traced to a dwarf galaxy 3 billion light-years away, suggests it could be the result of extreme astrophysical processes. For instance, interactions between a magnetar and its surrounding environment, such as a dense cloud of gas or a nearby black hole, could produce the repeating bursts we observe. What makes FRB 121102 so fascinating is not just its repeating nature, but also what it represents for the search for extraterrestrial intelligence. Its discovery has shown that not all FRBs are one-time events, and that some may hold the key to unlocking the secrets of the universe. By studying this signal, scientists hope to learn more about the conditions that produce such bursts and whether they could ever be linked to intelligent life. As we continue to explore the mysteries of FRB 121102, it serves as a reminder of how much we still have to learn about the cosmos. Each new observation brings us closer to understanding these enigmatic signals and their origins. Whether they are natural phenomena or something more, they challenge us to think beyond the boundaries of our current knowledge and imagine the possibilities that lie in the vast expanse of space. With that in mind, let's turn our attention to another intriguing signal, this time from the star Gliese 581G, which we'll explore in the next section. Now, let's shift our focus to a world that has captured the imagination of astronomers and dreamers alike. Gliese 581G, located approximately 20 light-years from Earth, this exoplanet orbits within the habitable zone of its star, Gliese 581, making it one of the most promising candidates for potentially hosting life. Gliese 581G is a rocky planet slightly larger than Earth, and its position in the habitable zone means it could have the right conditions for liquid water to exist on its surface. This alone makes it a fascinating target for scientists searching for signs of life beyond our solar system. But what truly sets Gliese 581G apart are the unconfirmed signals that some researchers believe could hint at the presence of intelligent life. In 2010, a team of astronomers reported detecting unusual radio signals coming from the direction of Gliese 581. These signals, though faint and unverified, sparked widespread speculation. Could they be a deliberate attempt at communication from an advanced civilization on Gliese 581G? The idea is tantalizing, but it's important to note that these signals have not been confirmed as artificial in origin. In fact, many scientists argue that they could be the result of natural phenomena or even interference from Earth-based sources. Despite the uncertainty, the possibility of intelligent life on Gliese 581G has fueled countless discussions and theories. Some have suggested that if life does exist there, it could be far more advanced than we are, given the planet's age and stability. Others have proposed that the signals, if real, might be part of a larger network of communication between civilizations scattered across the galaxy. Of course, the search for life on Gliese 581G is far from over. Future telescopes and advanced detection methods may one day provide clearer answers. For now, the planet remains a symbol of hope and curiosity in our quest to understand whether we are alone in the universe. As we ponder the mysteries of Gliese 581G, let's turn our attention to another groundbreaking discovery that reshaped our understanding of the cosmos, the LGM-1 pulsar, which we'll explore next. Now, let's journey back to a pivotal moment in the history of astronomy, the discovery of the LGM-1 pulsar. In 1967, a young graduate student named Jocelyn Bell Burnell made an extraordinary observation while analyzing data from a radio telescope. She noticed a series of regular, repeating pulses coming from deep space, occurring with such precision that they seemed almost artificial. At first, the signals were so unusual that Burnell and her team humorously labeled them LGM, short for Little Green Men, as they considered the possibility that these pulses might be a message from an extraterrestrial civilization. The pulses were unlike anything astronomers had ever seen before. They came at intervals of about 1.3 seconds with a consistency that defied natural explanations. The idea that they could be a deliberate signal from an intelligent species was both thrilling and unsettling. However, as further observations were made, it became clear that these signals were not the work of aliens but rather the result of a natural phenomenon, a rapidly spinning neutron star now known as a pulsar. This discovery was groundbreaking. Pulsars are the remnants of massive stars that have exploded in supernova, leaving behind incredibly dense cores that spin at astonishing speeds. As they rotate, they emit beams of radiation that sweep across space like a cosmic lighthouse, creating the regular pulses that Bernal detected. The LGM-1 pulsar, later named CP1919-1, was the first of its kind to be discovered, opening up an entirely new field of study in astrophysics. While the LGM-1 pulsar turned out not to be a message from aliens, its discovery had a profound impact on the search for extraterrestrial intelligence, or SETI. It highlighted the importance of distinguishing between natural and artificial signals in the vastness of space. This event also underscored the need for rigorous scientific analysis, as even the most tantalizing signals can have explanations rooted in the natural world. The story of the LGM-1 pulsar serves as a reminder of how close we can come to mistaking the wonders of the universe for signs of intelligent life. It also demonstrates the power of curiosity and careful observation in unraveling the mysteries of the cosmos. As we continue our exploration of mysterious messages from deep space, let's turn our attention to another intriguing signal, this time from our closest stellar neighbor, Proxima Centauri. Now, shifting our gaze to the star system closest to our own, we arrive at Proxima Centauri, a red dwarf star just over 4 light-years away. In 2020, astronomers detected a mysterious signal emanating from this nearby star, sparking excitement and speculation about its potential as a message from an extraterrestrial civilization. Known as the Proxima Centauri signal, this discovery quickly became one of the most intriguing candidates in the search for intelligent life beyond Earth. The signal, detected by the Breakthrough Listen project, stood out because of its narrow frequency range, which is often considered a hallmark of artificial transmission. Unlike the chaotic bursts of natural cosmic phenomena, this signal appeared to be carefully tuned, raising the possibility that it could be a deliberate attempt at communication. Adding to the intrigue, Proxima Centauri is known to host at least 2 planets, one of which, Proxima Centauri b, lies within the star's habitable zone, a region where liquid water could exist, making it a prime candidate for harboring life. However, as with many tantalizing signals from deep space, the Proxima Centauri signal came with its share of challenges. One of the primary difficulties in verifying its origin lies in the sheer complexity of distinguishing between natural and artificial sources. Radio interference from human-made technology, such as satellites or ground-based equipment, can often mimic the characteristics of an extraterrestrial signal. In fact, further analysis suggested that the Proxima Centauri signal might have been caused by a passing satellite or other terrestrial interference, casting doubt on its extraterrestrial origins. Despite these uncertainties, the detection of the Proxima Centauri signal highlights the importance of continued vigilance in the search for extraterrestrial intelligence. It serves as a reminder that even signals from our closest stellar neighbor require meticulous scrutiny to rule out all possible explanations. The Breakthrough Listen project, along with other SETI initiatives, continues to refine its methods, improving its ability to filter out interference and focus on signals that could truly originate from beyond our solar system. The Proxima Centauri signal also underscores the profound implications of discovering a message from another civilization. If such a signal were ever confirmed, it would not only revolutionize our understanding of the universe, but also raise profound questions about our place within it. As we move forward in our exploration of mysterious messages from deep space, let's turn our attention to another enigmatic object that has captured the imagination of scientists and the public alike, the interstellar visitor known as Oumuamua. Now turning our attention to one of the most perplexing objects ever observed in our solar system, we encounter Oumuamua, a visitor from beyond the stars. Discovered in October 2017, this interstellar object immediately captured the attention of astronomers and the public alike, not just for its origin but for its bizarre characteristics that defied easy explanation. Unlike any asteroid or comet we've seen before, Oumuamua's elongated, cigar-like shape and its peculiar acceleration as it traveled through our solar system sparked intense speculation. Could this mysterious traveler be more than just a natural object? Could it perhaps be an alien probe or spacecraft? Oumuamua's unusual trajectory was one of the first clues that set it apart. As it passed through our solar system, it didn't follow the predictable path of a typical comet or asteroid. Instead, it exhibited a slight but noticeable acceleration that couldn't be fully explained by gravity alone. This led some scientists to propose that Oumuamua might be equipped with some form of propulsion, such as a solar sail, a technology that uses sunlight to push a spacecraft through space. While this idea remains speculative, it opened the door to the tantalizing possibility that Oumuamua could be an artificial object sent by an advanced extraterrestrial civilization. Adding to the mystery was Oumuamua's shape. Most asteroids and comets are roughly spherical or irregular, but Oumuamua was estimated to be up to 10 times longer than it was wide, resembling a slender cigar or a flat pancake. This highly unusual form further fueled the imagination, as it didn't align with the typical characteristics of natural space debris. Some researchers even suggested that its shape could be optimized for interstellar travel, minimizing damage from collisions with dust and gas during its long journey through the void of space. Of course, not everyone was convinced that Oumuamua was an alien artifact. Many scientists argued that its peculiarities could be explained by natural phenomena. For instance, the acceleration could have been caused by outgassing, a process where a comet releases gas as it heats up, creating a small but detectable push. However, no visible coma or tail, which are typical signs of outgassing, were observed around Oumuamua, leaving this explanation incomplete. Others proposed that Oumuamua might be a fragment of a larger object, such as a shattered planet or a piece of a distant exoplanet, ejected into interstellar space by a cataclysmic event. Despite the ongoing debate, Oumuamua remains one of the most intriguing mysteries in modern astronomy. Its brief visit to our solar system left us with more questions than answers, challenging our understanding of what lies beyond our cosmic neighborhood. Whether it was a natural oddity or something more extraordinary, Oumuamua has undoubtedly expanded our perspective on the possibilities that exist in the vast expanse of space. As we continue to explore the mysteries of the cosmos, let's shift our focus to another enigmatic signal, this time from a star just 11 light-years away. The Ross 128 signal, detected in 2017, has its own set of peculiarities that have kept scientists and enthusiasts alike captivated. Now let's turn our gaze to a star much closer to home, Ross 128, located just 11 light-years away. In 2017, astronomers detected a peculiar signal emanating from this red dwarf star, sparking a wave of excitement and speculation. Unlike the usual radio noise from stars, this signal stood out for its unusual pattern, raising questions about its origin. Could this be a message from an alien civilization, or is there a more mundane explanation? The signal, observed by the Arecibo Observatory in Puerto Rico, was particularly intriguing because it appeared to be periodic, repeating at regular intervals. This kind of pattern is rare in natural cosmic phenomena, which tend to be more random. The signal also seemed to drift in frequency, a characteristic that some scientists suggested could be caused by the motion of a transmitter, such as a satellite orbiting a planet. This led to the tantalizing possibility that the signal might be artificial in nature, perhaps originating from a technologically advanced civilization on a planet orbiting Ross 128. However, as with many mysteries in astronomy, the truth is often more complex. Further analysis revealed that the signal's unusual characteristics could also be explained by human-made interference. Satellites in Earth's orbit, for example, often emit signals that can mimic the behavior of extraterrestrial transmissions. This raised the question of whether the Ross 128 signal was simply a case of mistaken identity, a cosmic mirage created by our own technology. Despite this, the signal's unique properties kept the debate alive. Some researchers pointed out that the frequency drift observed in the signal didn't perfectly match the patterns typically produced by satellites. This left room for the possibility that the signal could still be of extraterrestrial origin, though conclusive evidence remains elusive. The scientific community continues to monitor Ross 128, hoping to detect similar signals that could shed more light on this mystery. What makes the Ross 128 signal particularly fascinating is its proximity. At just 11 light-years away, Ross 128 is one of the closest stars to Earth, making it a prime candidate for the search for extraterrestrial intelligence. If a signal from this star were indeed artificial, it would suggest that intelligent life might be closer than we ever imagined. This prospect has fueled both scientific curiosity and public imagination, reminding us of the vast possibilities that lie within our cosmic neighborhood. As we ponder the mysteries of Ross 128, let's move on to another intriguing signal, this time from a star system that has captured the attention of astronomers for its potential to host life. The Kepler 438b signal offers its own set of enigmas, inviting us to explore the boundaries of what we know and what we have yet to discover. Now, shifting our focus to a world that has sparked both hope and intrigue, let's explore the Kepler 438b signal. Located approximately 640 light-years away, Kepler 438b is an exoplanet that has captured the attention of astronomers for its potential to host life. This distant world orbits within the habitable zone of its star, a region where conditions might be just right for liquid water to exist, a key ingredient for life as we know it. Kepler 438b is slightly larger than Earth, earning it the classification of a super-Earth. Its star, a red dwarf, is cooler and dimmer than our Sun, but the planet's proximity to it means it could still receive enough warmth to sustain a stable climate. This combination of factors has made Kepler 438b one of the most promising candidates in the search for habitable worlds beyond our solar system. But what truly sets this exoplanet apart are the unconfirmed signals that some researchers believe could hint at the presence of intelligent life. Over the years, faint and sporadic signals have been detected in the vicinity of Kepler 438b. These signals, though weak and inconsistent, have sparked speculation about their origin. Could they be the result of natural phenomena such as stellar activity or cosmic interference? Or might they be something more extraordinary, a deliberate attempt at communication from a civilization far beyond our own? One of the challenges in studying these signals is their intermittent nature. Unlike the periodic patterns observed in some other cosmic messages, the signals from Kepler 438b appear irregular, making them difficult to analyze. Some scientists argue that this irregularity could point to a natural source, such as flares from the planet's host star or interactions with its magnetic field. Others, however, suggest that the signal's unpredictability could be a deliberate feature, designed to avoid detection by less advanced civilizations. Adding to the mystery is the fact that Kepler 438b's host star is known to be highly active, emitting frequent flares that could interfere with any potential signals. This has led to debates within the scientific community about whether the signals are truly extraterrestrial in origin or simply the product of stellar noise. Despite these challenges, the possibility of intelligent life on Kepler 438b continues to captivate researchers and enthusiasts alike. What makes this exoplanet particularly compelling is its potential to challenge our understanding of habitability. If life, or even intelligent life, exists on Kepler 438b, it would suggest that red dwarf systems, once thought to be too volatile for life, could indeed harbor thriving civilizations. This would dramatically expand the scope of our search for extraterrestrial intelligence, opening up new frontiers in the exploration of the cosmos. As we continue to unravel the mysteries of Kepler 438b, let's turn our attention to another cosmic enigma, a repeating fast radio burst that has puzzled astronomers for years. The FRB 180916 repeater offers its own set of tantalizing clues, inviting us to delve deeper into the secrets of the universe. Now, let's journey into the realm of one of the most intriguing cosmic phenomena, the FRB 180916 repeater. Unlike the sporadic signals we've explored so far, this fast radio burst stands out for its remarkable regularity. Detected in 2019, this repeating burst follows a precise 16-day cycle, a pattern that has left scientists both fascinated and baffled. What could be causing such a consistent signal from the depths of space? Fast radio bursts, or FRB, are incredibly powerful bursts of radio waves that last just milliseconds. Most FRBs are one-off events, making them difficult to study. But the FRB 180916 repeater is different. Its repeating nature has allowed researchers to observe it more closely, revealing a pattern that repeats every 16 days. For 4 days, the burst emits multiple signals, and then it falls silent for 12 days before starting the cycle again. This rhythmic behavior is unlike anything else observed in the cosmos, sparking intense debate about its origin. One leading theory suggests that the signal could be coming from a highly magnetized neutron star known as a magnetar. Magnetars are known for their intense magnetic fields and occasional bursts of energy, which could explain the periodic nature of the FRB. However, the 16-day cycle is unusually long for such an object, raising questions about whether a magnetar alone could be responsible. Some scientists propose that the signal might be influenced by an orbiting companion, such as a black hole or another star, which could modulate the bursts into this distinct pattern. On the other hand, the possibility of an artificial origin cannot be dismissed. The regularity of the signal has led some to speculate that it could be a form of communication or even a beacon from an advanced extraterrestrial civilization. While this idea remains highly speculative, it's a tantalizing thought that underscores the mystery of the FRB 180916 repeater. Could this be a deliberate attempt to reach out across the vastness of space, or is it simply a natural phenomenon we have yet to fully understand? Adding to the intrigue is the location of the FRB. It originates from a spiral galaxy roughly 500 million light-years away, a relatively close distance in cosmic terms. This proximity has allowed astronomers to study the signal in greater detail, but it has also deepened the mystery. Why does this particular galaxy produce such a unique and repeating signal? Is there something special about its environment, or is it simply a coincidence? The FRB 180916 repeater challenges our understanding of the universe in profound ways. Its repeating pattern defies easy explanation, forcing scientists to rethink their assumptions about the nature of fast radio bursts. Whether it's a natural phenomenon or something more extraordinary, this signal reminds us of how much we still have to learn about the cosmos. As we ponder the mysteries of this repeating burst, let's turn our attention to another fascinating system, the TRAPPIST-1 system. With its 7 Earth-sized planets, this nearby star system offers its own set of tantalizing possibilities in the search for extraterrestrial life. Now, shifting our gaze to a star system that has captured the imagination of astronomers and space enthusiasts alike, we arrive at the TRAPPIST-1 system. Located just under 40 light-years from Earth, this system is home to 7 Earth-sized planets, 3 of which orbit within the star's habitable zone, the region where conditions might be just right for liquid water to exist. This makes TRAPPIST-1 one of the most promising places to search for signs of extraterrestrial life. The discovery of these planets in 2017 was a monumental moment in astronomy. Using data from the TRAPPIST telescope in Chile, scientists identified the planets as they passed in front of their host star, causing slight dips in its brightness. Further observations revealed that these worlds are not only similar in size to Earth, but also likely rocky, with the potential for atmospheres. This combination of factors has made the TRAPPIST-1 system a prime target in the search for life beyond our solar system. But what makes this system even more intriguing are the whispers of unconfirmed signals that some researchers believe could hint at intelligent life. While no definitive evidence has been found, there have been occasional anomalies in the data that have sparked curiosity. For instance, some studies have noted unusual patterns in the light passing through the planet's atmospheres, which could suggest the presence of complex molecules or even artificial structures. These findings, though speculative, have fueled the imagination of scientists and the public alike. One of the most fascinating aspects of the TRAPPIST-1 system is its compact nature. The planets are packed closely together, with some orbiting so near to one another that, if you were standing on the surface of one, you could see the neighboring planets in the sky, appearing larger than our moon does from Earth. This proximity raises intriguing questions about how life might evolve in such a dynamic environment. Could these planets share resources or even exchange life forms through meteorite impact? The possibilities are as vast as they are exciting. Despite the tantalizing potential, the search for signals from the TRAPPIST-1 system remains challenging. The distance, while relatively close in cosmic terms, still makes it difficult to gather detailed information. Current telescopes can only provide limited data about the planet's atmospheres and surfaces. However, upcoming missions like the James Webb Space Telescope promise to shed more light on these distant worlds, potentially revealing whether they harbor the ingredients for life or even signs of civilization. As we continue to explore the TRAPPIST-1 system, it's impossible not to wonder what secrets it might hold. Could one of these 7 planets be home to intelligent beings, sending out signals we have yet to detect? Or are the anomalies we've observed simply the result of natural processes we don't yet fully understand? The answers remain hidden in the depths of space, waiting for us to uncover them. With the mysteries of TRAPPIST-1 still unfolding, let's turn our attention to another intriguing signal, this time from the star Vega. What could this bright star, one of the most studied in the night sky, be trying to tell us? Now, let's journey to one of the brightest stars in our night sky, Vega. Located just 25 light-years from Earth, Vega has long been a subject of fascination for astronomers. But in 1983, this star became the center of an even greater mystery when a peculiar signal was detected emanating from its direction. This signal, unlike anything observed before, sparked intense speculation about its origin and whether it could be a message from an advanced extraterrestrial civilization. The signal, detected by a team of researchers using a radio telescope, stood out for its unusual characteristics. It was a narrowband signal, meaning it was concentrated in a very specific frequency range, a hallmark often associated with artificial transmissions rather than natural cosmic phenomena. What made it even more intriguing was its intermittent nature. The signal appeared to come and go, as if it were being deliberately controlled or modulated. This behavior raised questions about whether it could be a deliberate attempt at communication, rather than a random burst of cosmic noise. At the time, the discovery sent ripples through the scientific community. Some researchers proposed that the signal could be evidence of a highly advanced civilization attempting to make contact. Vega, after all, is a relatively young star, but its age still allows for the possibility of intelligent life having developed on any planets within its system. Others, however, cautioned against jumping to conclusions, pointing out that natural processes, such as stellar activity or interference from Earth-based sources, could also explain the signal's unusual properties. Despite decades of analysis, the true nature of the Vega signal remains unresolved. No follow-up detections have been made, leaving the 1983 event as a tantalizing one-off. Yet, it continues to captivate the imagination of scientists and enthusiasts alike. Could it have been a fleeting attempt at communication from a distant civilization? Or was it simply a cosmic coincidence, a rare but natural phenomenon that we have yet to fully understand? Vega's prominence in our night sky and its relative proximity to Earth make it a compelling target for future studies. As our technology advances, we may one day uncover more about this enigmatic star and the mysterious signal it once emitted. Until then, the Vega signal remains one of the most intriguing puzzles in the search for extraterrestrial intelligence, a reminder that the universe is full of surprises waiting for us to decode them. With Vega's mystery still lingering, let's turn our attention to another star that has sparked curiosity: Barnard's star. What secrets might this faint, fast-moving star hold, and could it too be sending signals we've yet to fully comprehend? Now, shifting our gaze to a star that has quietly intrigued astronomers for decades, we arrive at Barnard's star. This faint, fast-moving star, located just under 6 light-years from Earth, holds a unique place in the history of the search for extraterrestrial intelligence. In the 1960s, a series of unusual signals were detected from its direction, sparking a debate that continues to this day. Could these signals have been a deliberate attempt at communication, or were they simply the result of natural cosmic processes? The signals from Barnard's star were first picked up by researchers using radio telescopes. What made them stand out was their peculiar pattern. Unlike the random bursts of cosmic noise typically observed, these signals appeared to have a certain regularity, almost as if they were following a deliberate sequence. This raised eyebrows among scientists, as such patterns are often considered a potential indicator of artificial origin. The idea that an intelligent civilization might be behind these signals was tantalizing, especially given Barnard's star's proximity to Earth. However, not everyone was convinced. Skeptics pointed out that natural phenomena, such as stellar flares or interactions with nearby celestial objects, could also produce signals with seemingly regular patterns. The debate intensified as researchers tried to rule out these possibilities. Some argued that the signal's characteristics were too consistent to be purely natural, while others maintained that the universe is full of surprises, and what appears artificial might simply be a rare but natural occurrence. Adding to the intrigue was the fact that Barnard's star is one of the closest stars to our solar system, making it a prime candidate for harboring planets and potentially life. While no confirmed planets were known around Barnard's star at the time of the signal detections, the possibility of an undiscovered world with intelligent inhabitants fueled speculation. Could these signals have been a message from such a civilization, reaching out across the vastness of space? Despite extensive analysis, the true nature of the Barnard star signals remains unresolved. No follow-up detections have been made, leaving the 1960s event as another tantalizing mystery in the annals of astronomy. Yet, the questions it raised continue to inspire research and exploration. As our technology improves, we may one day uncover more about this enigmatic star and the signals it once emitted. Until then, Barnard's star serves as a reminder that even the faintest points of light in our night sky can hold profound secrets. With the mystery of Barnard's star still lingering, let's turn our attention to another intriguing signal, this time from the star Tau Ceti. What could this nearby star be trying to tell us, and how might it fit into the larger puzzle of extraterrestrial communication? Moving forward in our journey through the cosmos, we now turn our attention to Tau Ceti, a star that has long captured the imagination of astronomers and science fiction enthusiasts alike. Located just under 12 light-years from Earth, Tau Ceti is one of the closest Sun-like stars to our solar system, making it a prime candidate in the search for extraterrestrial life. In 2004, a peculiar signal was detected from this star, reigniting hopes and debates about the possibility of intelligent communication from beyond our world. The signal, detected by researchers using advanced radio telescopes, stood out due to its unusual characteristics. Unlike the random noise typically picked up from distant stars, this signal appeared to have a distinct pattern, raising questions about its origin. Could this be a deliberate attempt at communication from an advanced civilization orbiting Tau SETI, or was it simply another cosmic coincidence? The idea of a message from such a nearby star was both thrilling and humbling, as it suggested that we might not be alone in the universe. However, as with many mysterious signals, the excitement was tempered by skepticism. Scientists quickly pointed out that natural phenomena, such as stellar activity or interference from Earth-based sources, could also produce signals that mimic artificial patterns. The challenge lay in distinguishing between these possibilities. Researchers meticulously analyzed the signal, searching for clues that might reveal its true nature. Was it a fleeting burst of cosmic energy or something far more significant? Adding to the intrigue is the fact that Tau SETI is known to host a system of planets, some of which lie within the star's habitable zone, the region where conditions might be right for liquid water and potentially life. While no definitive evidence of life has been found, the presence of these planets makes Tau SETI an even more compelling target for investigation. Could the signal have originated from one of these worlds, perhaps as a beacon from an intelligent species trying to make contact? Despite extensive efforts, the origin of the 2004 Tau SETI signal remains a mystery. No follow-up detections have been made, leaving scientists with more questions than answers. Yet, the signal serves as a reminder of the vast possibilities that lie within our cosmic neighborhood. As our technology continues to advance, we may one day uncover the truth behind this enigmatic message. Until then, Tau SETI remains a symbol of hope and curiosity in our ongoing quest to understand the universe and our place within it. With Tau SETI's mystery still unresolved, let's now explore another fascinating signal, this time from the distant exoplanet Kepler 186f. What secrets might this far-off world hold, and could it be another piece of the puzzle in our search for extraterrestrial intelligence? Now, let's venture even further into the cosmos to Kepler 186f, an exoplanet that has sparked both excitement and speculation in the scientific community. Discovered in 2014 by NASA Kepler Space Telescope, this distant world lies approximately 500 light-years away from Earth, orbiting a red dwarf star within the constellation Cygnus. What makes Kepler 186f particularly intriguing is its location within its star's habitable zone, a region where temperatures could allow for the presence of liquid water, a key ingredient for life as we know it. Kepler 186f is one of 5 known planets in its system, but it stands out due to its Earth-like size and potential for stable conditions. While it's slightly larger than our own planet, its rocky composition and position in the habitable zone have led scientists to consider it a prime candidate for further study in the search for extraterrestrial life. But what truly captured the attention of researchers and enthusiasts alike were the faint, unconfirmed signals that some believe could hint at intelligent activity on this distant world. These signals, detected intermittently over the years, have been the subject of intense debate. Unlike the random noise typically associated with cosmic phenomena, the patterns observed in these signals appear to have a certain regularity, raising questions about their origin. Could they be the result of natural processes, such as magnetic storms or interactions between the planet and its star? Or might they be something far more extraordinary, a deliberate attempt at communication from an advanced civilization? The challenge, as with many signals from deep space, lies in determining their true nature. Scientists have carefully analyzed the data, searching for patterns or anomalies that could provide clues. While no definitive evidence of intelligent life has been found, the possibility remains tantalizing. The idea that a world so far away could harbor life, or even a civilization capable of sending signals across the vastness of space, fuels our curiosity and drives the search for answers. Adding to the intrigue is the fact that Kepler 186f star is much cooler and dimmer than our Sun. which could influence the planet's climate and potential for habitability. Some researchers speculate that if life does exist there, it might have evolved in ways vastly different from what we're familiar with on Earth. This raises fascinating questions about the diversity of life in the universe and the forms it might take. As of now, the signals from Kepler 186f remain unconfirmed, leaving their origin shrouded in mystery. Yet, they serve as a reminder of the boundless possibilities that await us in the cosmos. Each signal, each discovery brings us one step closer to answering the age-old question: are we alone in the universe? With every new piece of data, we inch closer to uncovering the truth, and Kepler 186f remains a beacon of hope and wonder in our ongoing exploration of the stars. As we ponder the mysteries of Kepler 186f, let's shift our focus to another enigmatic signal, this time from the fast radio burst known as FRB 190523. What secrets might this fleeting cosmic phenomenon hold, and could it be another clue in our quest to understand the universe? Turning our attention to another cosmic enigma, we encounter the fast radio burst known as FRB 190523. Detected in 2019, this brief but intense burst of radio waves has left scientists both fascinated and puzzled. Lasting just milliseconds, FRB 190523 released an astonishing amount of energy equivalent to what our Sun produces over several decades. Yet, despite its fleeting nature, this signal has sparked a wave of curiosity and debate about its origins. Fast radio bursts, or FRB, are among the most mysterious phenomena in the universe. They appear suddenly, vanish almost instantly, and often come from unimaginably distant corners of space. FRB 190523 is no exception. Detected by the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, this burst originated from a galaxy billions of light-years away. Its immense distance raises questions about what could possibly generate such a powerful signal across such vast cosmic expanses. One of the leading theories suggests that FRB 190523 could be the result of natural astrophysical processes. Some scientists propose that it might have been produced by highly magnetized neutron stars known as magnetars. These dense, rapidly spinning stellar remnants are capable of releasing enormous bursts of energy, which could explain the intensity of FRBs. Another possibility is that the burst was caused by the collision of two neutron stars or the collapse of a massive star into a black hole. These cataclysmic events could generate the kind of energy needed to produce such a signal. However, the mystery deepens when we consider the possibility of artificial origins. Could FRB 190523 be a deliberate signal from an advanced extraterrestrial civilization? While this idea may sound like science fiction, it's a hypothesis that some researchers take seriously. The sheer power and precision of the burst have led to speculation that it might be a form of communication or even a byproduct of advanced alien technology. For instance, some have suggested that such bursts could be used to power interstellar spacecraft or transmit information across the cosmos. Despite these intriguing possibilities, the true nature of FRB 190523 remains uncertain. Scientists continue to analyze the data, searching for patterns or clues that could shed light on its origin. One challenge is the burst's brevity. By the time telescopes can pinpoint its location, the signal has already faded, leaving only traces of its existence. This makes it difficult to study in detail and adds to the mystery surrounding these cosmic flashes. What makes FRB 190523 particularly fascinating is its potential to expand our understanding of the universe. Whether it's a natural phenomenon or something more extraordinary, each fast radio burst offers a glimpse into the extreme conditions and processes that shape our cosmos. As we uncover more about these enigmatic signals, we inch closer to answering some of the most profound questions about the nature of the universe and our place within it. With FRB 190523 still shrouded in mystery, our journey through the cosmos continues. Next, we'll explore another intriguing signal, this time from the star Wolf 359, and delve into the questions it raises about the possibility of extraterrestrial communication. Now let's turn our gaze to a star much closer to home, Wolf 359. Located just under 8 light-years from Earth, this red dwarf star has long been a point of interest for astronomers. But in 1997, it became the center of attention when a peculiar signal was detected emanating from its direction. This signal, unlike anything observed before, sparked intense speculation and debate about its origin and what or who might have sent it. The Wolf 359 signal was first picked up by the Big Ear radio telescope in Ohio, the same instrument that famously detected the WOW signal 2 decades earlier. What made this signal stand out was its unusual pattern. Unlike natural radio emissions from stars, which tend to be chaotic and irregular, the Wolf 359 signal appeared to have a structured, almost rhythmic quality. This raised immediate questions. Could this be a deliberate transmission from an intelligent source, or was it simply a rare and unexplained natural phenomenon? One of the most intriguing aspects of the signal was its frequency. It was detected at a frequency of 1,420 MHz, a range often associated with hydrogen, the most abundant element in the universe. This frequency is also considered a potential waterhole for interstellar communication, as it lies between the natural emissions of hydrogen and hydroxyl molecules, 2 components of water. Some researchers have suggested that this frequency could be a deliberate choice by an advanced civilization, as it represents a universal symbol of life. However, skepticism remains. Critics argue that the signal's unusual characteristics could be the result of terrestrial interference or an unknown astrophysical process. For instance, red dwarf stars like Wolf 359 are known for their intense magnetic activity, which can produce bursts of radio waves. These bursts, while rare, could potentially mimic the structured patterns observed in the signal. Additionally, the signal was never detected again, making it difficult to study further or confirm its origin. Despite the uncertainty, the Wolf 359 signal continues to captivate the imagination of scientists and enthusiasts alike. Its proximity to Earth makes it a tantalizing target for further investigation, as it lies within what some consider the neighborhood of our solar system. If the signal were indeed artificial, it would suggest that intelligent life might exist much closer to us than previously thought. This possibility has fueled ongoing efforts to monitor Wolf 359 and other nearby stars for similar signals. As we ponder the mysteries of the Wolf 359 signal, we're reminded of the vastness of the cosmos and the endless possibilities it holds. Whether this signal was a fleeting natural phenomenon or a deliberate message from another civilization, it underscores the importance of continuing our search for answers. Next, we'll explore another intriguing cosmic mystery, this time from the distant exoplanet Kepler 62f, and the signals that have sparked curiosity about its potential for harboring life. Now, let's journey to a distant world that has captured the imagination of astronomers and space enthusiasts alike. Kepler 62f. Located approximately 1,200 light-years from Earth, this exoplanet orbits within the habitable zone of its star, a region where conditions might be just right for liquid water to exist. Discovered by the Kepler Space Telescope in 2013, Kepler 62f is one of the most promising candidates for a potentially habitable world beyond our solar system. But what makes this exoplanet even more intriguing are the unconfirmed signals that some believe could hint at the presence of intelligent life. Kepler 62f is part of a 5-planet system, but it stands out due to its size and location. With a radius about 1.4 times that of Earth, it's classified as a super-Earth, a type of planet that could have a rocky surface and possibly even an atmosphere. Its orbit within the habitable zone raises the tantalizing possibility that it could host oceans, continents, and perhaps even life. However, the real mystery lies in the faint, unexplained signals that have occasionally been detected in its direction. These signals, though unconfirmed, have sparked speculation about whether they could be artificial in origin. The signals associated with Kepler-62f are faint and sporadic, making them difficult to study in detail. Some researchers have suggested that these emissions could be the result of natural phenomena, such as magnetic storms or interactions between the planet and its star. Others, however, have proposed a more exciting possibility, that the signals could be evidence of advanced technology or communication attempts by an intelligent civilization. The idea is not without precedent. In the search for extraterrestrial intelligence, or SETI, scientists often look for patterns or anomalies in radio waves that could indicate deliberate transmissions. One of the challenges in studying these signals is their distance. At 1,200 light-years away, any potential message from Kepler-62f would have been sent over a millennium ago, long before human civilization as we know it existed. This vast distance also means that confirming the origin of the signals is incredibly difficult. Without repeated detections or additional data, the mystery remains unresolved. Yet the possibility of a habitable world with potential signs of intelligence continues to fuel scientific curiosity and public fascination. What makes Kepler-62f particularly compelling is its potential to host life as we understand it. Its location in the habitable zone, combined with its Earth-like size, makes it a prime candidate for further study. Future telescopes, such as the James Webb Space Telescope, could provide more insights into its atmosphere and surface conditions, potentially revealing whether it has the ingredients necessary for life. And while the signals remain unconfirmed, they serve as a reminder of the vast possibilities that lie within our universe. As we reflect on the mysteries of Kepler-62f, we're reminded of the profound questions that drive our exploration of the cosmos. Could this distant world be home to another civilization? Or are the signals simply the echoes of natural processes we have yet to fully understand? Whatever the answer, Kepler-62f stands as a beacon of hope and curiosity in our ongoing search for life beyond Earth. Next, we'll delve into another enigmatic signal, this time from the fast radio burst known as FRB 200428, and explore what it might reveal about the universe's most elusive phenomena. Now, let's turn our attention to one of the most fascinating cosmic mysteries of recent years, the fast radio burst known as FRB 200428. Detected in April 2020, this burst of energy lasted just milliseconds but carried the power of hundreds of millions of suns. What makes this particular FRB so remarkable is that it was traced back to a known source within our own galaxy, a first in the study of these enigmatic signals. This discovery has opened up new avenues for understanding what causes these fleeting yet incredibly powerful bursts of radio waves. FRB 200428 originated from a magnetar, a highly magnetized neutron star located about 30,000 light-years from Earth. Magnetars are known for their intense magnetic fields, which can be trillions of times stronger than Earth's. The detection of this FRB from a magnetar has led scientists to consider whether these extreme objects could be the source of at least some fast radio bursts. This finding has been a game-changer as it provides a tangible explanation for a phenomenon that has puzzled astronomers for over a decade. However, not all FRBs fit neatly into this explanation. While FRB 200428's origin seems clear, many other fast radio bursts come from distant galaxies far beyond our Milky Way. These bursts are often one-time events, making them incredibly difficult to study. Some researchers have proposed that these distant FRBs could be caused by cataclysmic events, such as the collision of neutron stars or the collapse of massive stars into black holes. Others have entertained the possibility that they could be artificial in nature, perhaps signals from advanced extraterrestrial civilizations attempting to communicate across the cosmos. The idea that FRBs could be artificial is not as far-fetched as it might seem. Their brief, intense nature makes them ideal for transmitting information over vast distances, as they can cut through the noise of the universe. Some scientists have even speculated that advanced civilizations might use FRBs as a form of interstellar communication or as a way to power spacecraft. While there's no direct evidence to support this theory, it's a tantalizing thought that adds another layer of intrigue to these mysterious signals. What sets FRB 200428 apart is the wealth of data it has provided. Because it originated within our galaxy, astronomers were able to observe it in unprecedented detail. This has allowed them to study the properties of the burst and its source, shedding light on the mechanisms that could produce such powerful emissions. The discovery has also raised new questions about the diversity of FRBs and whether all of them share a common origin or if there are multiple causes behind these cosmic flashes. As we continue to unravel the mysteries of fast radio bursts, FRB 200428 stands as a pivotal moment in our understanding. It has shown us that magnetars can produce these bursts, but it has also reminded us of the vast unknowns that still surround this phenomenon. Are all FRBs natural, or could some be the work of intelligent beings? The answer remains elusive, but each discovery brings us closer to understanding the true nature of these enigmatic signals. Next, we'll explore the broader implications of FRBs and how they might shape our search for extraterrestrial intelligence in the years to come. Now, let's take a closer look at the groundbreaking implications of FRB 200428 and how it has reshaped our understanding of fast radio bursts. This particular burst, detected in April 2020, marked a turning point in the study of these mysterious signals. For the first time, astronomers were able to trace an FRB back to a specific source within our own galaxy, a magnetar. This discovery not only confirmed that magnetars can produce these bursts, but also provided a rare opportunity to study the phenomenon up close. Magnetars are among the most extreme objects in the universe. These highly magnetized neutron stars possess magnetic fields trillions of times stronger than Earth's, capable of warping space and time around them. The fact that FRB 200428 originated from such a source has led scientists to reconsider the mechanisms behind fast radio bursts. One leading theory suggests that the intense magnetic fields of magnetars can trigger sudden releases of energy, resulting in these brief but incredibly powerful bursts of radio waves. This explanation aligns with the observed properties of FRB 200428, offering a plausible natural cause for at least some of these signals. However, the story doesn't end there. While FRB 200428 has provided valuable insights, it has also highlighted the complexity of fast radio bursts as a whole. Not all FRBs fit the magnetar model. Many originate from distant galaxies far beyond the Milky Way, and their sources remain unidentified. This raises the question, are all fast radio bursts caused by magnetars, or are there multiple mechanisms at play? Some researchers propose that cataclysmic events, such as the collision of neutron stars or the collapse of massive stars, could also produce FRBs. Others speculate that these bursts might even be artificial in nature, potentially serving as signals from advanced extraterrestrial civilizations. The idea of FRBs as artificial signals is particularly intriguing. Their short duration and immense power make them ideal for transmitting information across vast cosmic distances. Some scientists have theorized that advanced civilizations might use FRBs as a form of interstellar communication or even as a means to power spacecraft. While this remains speculative, it adds an exciting layer of possibility to the study of these enigmatic signals. The discovery of FRB 200428 has not only deepened our understanding of magnetars, but also reignited the debate about the potential for intelligent life behind some of these bursts. What makes FRB 200428 truly remarkable is the wealth of data it has provided. Because it originated within our galaxy, astronomers were able to observe it in unprecedented detail. This has allowed them to study the burst's properties, such as its frequency, intensity, and polarization, shedding light on the physical processes that produce these emissions. The findings have also prompted new questions about the diversity of FRBs and whether they share a common origin or arise from a variety of cosmic phenomena. As we continue to explore the mysteries of fast radio bursts, FRB 200428 serves as a pivotal piece of the puzzle. It has shown us that magnetars can produce these bursts, but it has also reminded us of the vast unknowns that still surround this phenomenon. Are all FRBs natural, or could some be the work of intelligent beings? The answer remains elusive, but each discovery brings us closer to understanding the true nature of these cosmic enigmas. Next, we'll delve into how these findings are shaping the future of our search for extraterrestrial intelligence and what they might mean for our place in the universe. Turning our attention to the scientific advancements sparked by FRB 200428, this discovery has revolutionized the way we study fast radio bursts. For the first time, researchers had a close-up view of an FRB's origin, allowing them to analyze its properties with unprecedented precision. This burst, originating from a magnetar within our galaxy, provided a wealth of data that has reshaped our understanding of these cosmic phenomena. By studying its frequency, polarization, and energy distribution, scientists have gained critical insights into the mechanisms that produce such powerful bursts of radio waves. One of the most significant breakthroughs has been the confirmation that magnetars can indeed generate fast radio bursts. This finding has validated long-standing theories about the role of these highly magnetized neutron stars in producing FRBs. The intense magnetic fields of magnetars, trillions of times stronger than Earth's, create conditions ripe for sudden energy releases. These releases, in turn, generate the brief but incredibly powerful radio signals we detect as FRBs. This discovery has not only solved part of the mystery, but also opened new avenues for studying magnetars and their behavior. Beyond magnetars, FRB 200428 has also highlighted the diversity of fast radio bursts. While this burst fits the magnetar model, many others do not. Some FRBs originate from distant galaxies, and their sources remain unidentified. This has led scientists to explore alternative explanations, such as cataclysmic events like neutron star collisions or the collapse of massive stars. The data from FRB 200428 has provided a benchmark for comparing these different types of bursts, helping researchers identify patterns and anomalies that could point to multiple origins. The study of FRB 200428 has also advanced our technological capabilities. Detecting and analyzing such a burst required cutting-edge radio telescopes and sophisticated data processing techniques. These tools have since been refined and applied to other FRBs, improving our ability to detect and study these elusive signals. This technological progress has not only deepened our understanding of FRBs, but also enhanced our capacity to explore other cosmic phenomena. Perhaps most intriguingly, FRB 200428 has reignited discussions about the potential for artificial origins of some fast radio bursts. While the magnetar explanation fits this particular burst, the possibility that other FRBs could be signals from advanced extraterrestrial civilizations remains an open question. The immense power and short duration of FRBs make them ideal candidates for interstellar communication, and some scientists have even speculated that they could be used to power spacecraft. While this idea is still speculative, it adds an exciting dimension to the ongoing study of these signals. As we look to the future, the insights gained from FRB 200428 will continue to guide our exploration of fast radio bursts. This discovery has not only answered key questions but also raised new ones, driving the scientific community to push the boundaries of our knowledge. With each new observation, we move closer to unraveling the mysteries of these enigmatic signals and understanding their place in the cosmos. Next, we'll explore how these findings are shaping the future of our search for extraterrestrial intelligence and what they might mean for humanity's place in the universe. As we venture further into the realm of fast radio bursts, the discoveries sparked by FRB 200428 have set the stage for an exciting future in cosmic exploration. This groundbreaking event has not only deepened our understanding of these enigmatic signals, but also opened up new possibilities for what we might uncover next. The potential for future discoveries related to fast radio bursts is immense, and their significance in the search for extraterrestrial intelligence cannot be overstated. One of the most promising avenues for future research lies in the development of more advanced detection technologies. With each new generation of radio telescopes, our ability to capture and analyze fast radio bursts improves dramatically. Upcoming projects such as the Square Kilometre Array promise to revolutionize our capacity to detect even the faintest and most distant FRBs. These advancements will allow scientists to gather more detailed data, potentially revealing patterns or characteristics that could hint at their origins. The more we learn about these bursts, the closer we may come to determining whether they are natural phenomena or something far more extraordinary. Another exciting prospect is the possibility of identifying repeating fast radio bursts with greater precision. While FRB 200428 was a single, powerful event, other FRBs have been observed repeating at regular intervals. Understanding why some bursts repeat while others do not could provide critical clues about their sources. For instance, if repeating FRBs are found to originate from specific types of celestial objects or regions, it could help narrow down the list of potential explanations. This, in turn, could bring us closer to answering the ultimate question: are these signals natural, or could they be evidence of intelligent life? The search for extraterrestrial intelligence, or SETI, has long been intertwined with the study of fast radio bursts. The sheer power and brevity of these signals make them ideal candidates for interstellar communication. If an advanced civilization were to send a message across the cosmos, an FRB could be an efficient way to do so. While the Magnetar explanation fits FRB 200428, the diversity of FRBs leaves room for speculation. Future discoveries could reveal bursts with characteristics that defy natural explanations, reigniting the debate about their potential artificial origins. Moreover, the study of fast radio bursts has broader implications for our understanding of the universe. These signals travel vast distances, passing through galaxies, gas clouds, and other cosmic structures. By analyzing how FRBs are affected by these environments, scientists can gain insights into the composition and distribution of matter in the universe. This makes FRBs not only a tool for studying their own origins, but also a powerful probe for exploring the cosmos on a grand scale. As we look ahead, the mysteries surrounding fast radio bursts continue to captivate scientists and enthusiasts alike. Each new discovery brings us closer to unraveling their secrets, whether they are natural phenomena or something more profound. The journey to understand these signals is far from over, and the potential for groundbreaking revelations remains high. With every burst detected, we take another step toward answering one of humanity's most profound questions. Are we alone in the universe? Next, we'll wrap up our exploration of these 25 mysterious messages from deep space, reflecting on their significance and what they mean for our ongoing quest to understand the cosmos. As we bring our journey through these 25 mysterious messages from deep space to a close, it's clear that each signal holds a unique piece of the cosmic puzzle. From the enigmatic WOW signal to the groundbreaking FRB 200428, these messages have captivated scientists and dreamers alike, offering tantalizing glimpses into the vast unknown. Whether they are natural phenomena or potential signs of intelligent life, each discovery pushes the boundaries of our understanding and fuels our curiosity about the universe. These signals remind us of the sheer scale and mystery of the cosmos. They challenge us to think beyond our planet and consider the possibility that we are not alone. The search for extraterrestrial intelligence is not just about finding answers, it's about asking the right questions. What if one of these signals is a deliberate message from another civilization? What would that mean for humanity? The implications are profound, touching on everything from science and philosophy to our place in the universe. As we continue to explore the stars, each new discovery brings us closer to unraveling these cosmic mysteries. The advancements in technology, the dedication of scientists, and the sheer wonder of the unknown keep this quest alive. The journey is far from over, and the next breakthrough could be just around the corner. So, what do you think? Could one of these mysterious messages be the key to unlocking the greatest discovery in human history? Share your thoughts in the comments below. We'd love to hear your theories and ideas. And if you're as fascinated by the mysteries of the cosmos as we are, don't forget to subscribe and hit the notification bell for more deep dives into the wonders of space. The universe is full of secrets waiting to be uncovered, and we're just getting